Hello everyone, this is your teacher Ines Shabani from the Physics Department in the Exact Sciences faculty from University of Constantine I. I'm presenting to you an overview about the course entitled Fluid Mechanics, Practical Work, or as you know it, TP, in the context of the About video required for the training of the newly recruited teachers. When it comes to the targeted audience, this course will be targeting second year LMD physics students, and it will be taught in the fourth semester. It has 3 credits and a coefficient of 2. It will be taught for 3 hours per week, which will result in 45 hours per semester. This module will focus on experimental fluid mechanics. When it comes to the learning outcomes, the students at the end will be able to understand fundamental fluid mechanic concepts, distinguish flow regimes, and master flow rate measurement techniques, along with the development of experimental and data collection skills, and at the end, the comparison of theory and experimental data. When it comes to the prerequisites, the students all should have some fundamental physics background, scientific reasoning, laboratory safety awareness, and of course basic Microsoft Excel skills, which will help in the making of the reports. This TP or this course will be assessed by TP reports and final practical examination 50% 50% through a continuous engagement, of course, during laboratory sessions, which will have some impact on the TP report grade at the end. When it comes to the module plan, this course is divided into 3 TPs. The first one regarding the flow measurements, in which we'll see flow types from laminar to turbulent and the turbine flow meter. The second TP is the thin-walled weir, in which we'll verify the flow rate law, which we already saw in the first TP, and determine the discharge coefficient, which at the end will help us figure out the error margin in this experiment. And finally, the hydrostatic pressure force. In this TP, will be dealing with hydrostatic force experimentally and theoretically, and at the end, we'll make a moment equilibrium analysis. When it comes to the teaching approach, there would be a short theoretical introduction, a guide laboratory experiment, data analysis and interpretation, of course, of the collected data experimentally or the calculated data theoretically. There would be a scientific report writing at the end by the students in the session itself, and of course, all of this should the students should have an active participation spirit. At the end, these are the details of the TP, and if you have any questions, please contact me in my email. Thank you for your attention.